All right, here we go. Unit 5, Lesson 11, Rational Exponents. This is the last lesson that we have on this unit that focused a lot on exponent rules. And so today we're going to be focusing on rational exponents. And remember, that word rational doesn't mean logical like you might expect. It actually comes from ratio, right? Or fraction, more or less. So basically, we're talking about fractional exponents. And so here's sort of a motivating example. If I take the square root of x squared, right? And so what that means means take the square root of x and multiply it by itself. Well, we know what this is, right? You can either just say, okay, the square root means what times itself is x, and if you multiply that back, you should just get x, right? If you really want to think about it a lot, you could say, okay, that's the square root of x squared. Okay, that's x. So this is just x. And that leads us to the following implication. It leads us to the fact that the square root of x as an exponent must be x to the 1/2 power, which we have not seen before, fractional exponents. Because if you think about your exponent rules, they say if you raise a power to a power, they multiply. So this power, right, times 2 has to be 1, so it has to be x to the 1/2. And so that's just sort of like the motivating example for the rule I'm about to give you about rational exponents. Here's how rational exponents work. If you have x to the m over n, I know it's weird to use those two letters, but that's just historically what is done. The root number is the denominator, meaning the bottom number, the n as in Nancy in that fraction. The exponent is the numerator. And so what this becomes is the nth root of x to the m power. And so this is an important thing to sort of commit to memory. This is just what these rational exponents mean. X to the m over n would be the nth root of x to the power of m. And so let's think here about what does that nth root mean and all of that. The ones you want to use to remember what these mean, to memorize this, are the x to the 1/2 and x to the 1/3. And so x to the 1/2, remember we said the denominator is the root number. When you have a square root, this is an understood little 2 here, meaning what times itself, so that there are 2 of them. X times x, or like square root of x times square root of x gives us x, and there's an understood 1 here from the denominator. So you definitely have to have that memorized, but the one that's actually more helpful is to remember the cube root, that x to the 1/3 power is the cube root of x. So here are just like a couple of examples with real numbers. 16 to the 1/2 power. That means the square root of 16, which would be 4. 8 to the 1/3 power. That means the cube root of 8, meaning what times itself 3 times is 8, and that answer is 2, because 2 times 2 times 2 is 8. And so just running through a couple of quick examples here, when the numerator is not 1, it's an exponent on what's inside the radical. So x to the 2/5 would be the 5th root of x squared. Now, this is the same thing as, and you will sometimes see this written as, the 5th root of x squared. Those two things are exactly the same. Usually I prefer the top notation. And so x to the 7/5, the first thing I do is I write my radical with my x inside, and then I have to think for a second, okay, does 7 go inside or 7 go outside? Then x to the 1/3 is a cube root. So that means the 5, the denominator, has to go here, the 7 has to go there, and so on and so forth. So 32 to the 1/5 is the 5th root of 32 to the first power, just kind of understood there, which is 2, because 2 times itself 5 times is 32. We'll keep going. If we had AB to the 2/3, we're going to have AB in parenthesis there. Denominator is the root number and squared. If we had 4 to the 2/3, we would have the cube root of 4 squared. The cube root of 4 squared. Or since it's a real number, we can get a little bit more simple here. We can say 3, the cube root of 16. All right, just wrapping this up with a few more examples here. If you go from a radical to a rational exponent, you are just doing this backwards. So the cube root of 20 is 20 to the 1/3 power. The fourth root of c cubed is c to the 3/4 power. The fifth root of xy is xy in parenthesis to the 1/5 power. The reason it has to be in parenthesis is because all of xy is getting the fifth root applied to it. If you just wrote this, it would only apply to the y. So we don't write it like that. We have to keep that parenthesis. Last thing here today, again, really quick lesson here for today. All of our normal exponent rules apply. So if we had the fourth root of 7 times the square root of 7, the way I would do this is I would first convert into fractional exponent form. So that's why these are really useful, is that we can apply our exponent rules. The fourth root of 7, 7 to the 1/4. The square root of 7, 7 to the 1/2. Our exponent rule says we add those exponents. So this is, if I make them both have the same denominator, this is 7 to the 1/4 times 7 to the 2/4, right? Because that's the same thing as 1/2, makes it clear that this is 7 to the 3/4 power. And this would be the final answer. If you wanted to, you could convert this back. This is the fourth root of 7 cubed. Just a couple more examples here. This would be x squared over x to the 1/4 power. This would be x to the 2 minus 1/4. When we apply our exponent rules, this would be x to the, 2 would be 8/4 minus 1/4. This would be x to the 7/4 there. Final example, and that's going to be it for today. If we have the power to power rule. So the first thing I would do, again, first thing I always do is just convert these. The cube root of x squared is x to the 2/3 times the sixth root of x to the 4th is x to the 4/6. All of this is to the negative third power. I'm just going to keep doing one step at a time. I'm going to multiply these. That's going to be x to the 2/3 plus 4/6. Okay, 2/3 is also 4/6. So this becomes 8/6. So we have x to the, which reduces to 4/3. And normal fraction reducing applies. So this is x to the 4/3. This is x to the 4/3 here, all to the negative third power. Power to power rule applies. This is x to the 4/3 times -3, negative 12 over 3, x to the negative 4th, 1 over x to the 4th, or x to the negative 4th as fully simplified final answers there. I'll upload this note sheet so you can reference it while working on your Delta Math today, but that's it for rational exponent rules.